We're going to build quadratic models from word problems. Here's a word problem from your textbook. It says the price P in dollars and the quantity X sold of a certain product obey the demand equation. X is equal to negative 20P plus 500, where P is between 0 and 25. We want to express the revenue as a function of P. And then what is the revenue if the price is $24? What price P maximizes revenue? What's the maximum revenue? How many units are sold at this price? And what price should the company charge to earn at least $3,000 in revenue? So we have a lot going on for this problem. Let's break it down. So we are charging price P for some item that we're selling, and this P is going to be between 0 and $25. And it can't equal 0, but it can equal 25. Now revenue is the money that you bring in. So the revenue is different than the profit. So for example, if I sell something for $30, some object that I made, it costs me to make the object as well. So profit is the revenue minus the cost, and revenue is just what I bring in before I get rid of any costs. So for part A, we want to express the revenue, R, as a function of P. So we want just P's in our equation. So this is the demand equation. And this tells us how many objects we're going to sell. So if we sell X amount of objects and we sell them at a particular price, then if we multiply X by the price, that will tell us how much money we bring in. So the revenue is the price per object times the number of objects. So if I sold 2 objects for $30, 2 times 30 is 60, so I would bring in $60. So that's what we're going to do here. The price per object is given by P. So this piece is just P. And the number of objects is the demand, how many objects we're trying to sell. And that is given by this function X. So it's P times X, right? But because I want the revenue just to be a function of P, I'm going to put, instead of X, negative 20P plus 500, because that's what X is equal to. So I'm going to multiply this by negative 20P plus 500. So the revenue is P times negative 20P plus 500. And let's clean this up a little bit. The revenue of P is negative 20P squared plus 500P. Okay, let's look at this equation. This is a quadratic because I have an X, well, not an X, but a P squared term here. And then I have a P term, and then I have a plus 0. So you can see it's a quadratic function. Also, the number in front of the P squared is negative, so it's pointing downward. Okay? So we've done part A. Let's look at part B. What is the revenue if the price is $24? So we're going to charge $24 for our object. Now, $24 is pretty close to $25. So let's think about this a little bit. If we're selling an object, the cheaper we sell it, you probably would have more demand. More people would buy a less expensive object than a more expensive object. And that makes sense. If you look right here, you can see that the higher the price, so if you didn't sell it at all, you would have a demand of 500. If you, if you didn't charge anything for the price, if P was 0, then you would sell 500 of them. But for every dollar you increase in the price, you're going to sell 20 less. So if we charge $1 for P, well, that's times -20. So subtract 20, you get 480. So if we sold this item for $1, we would sell 480 of them. And then our profit, or sorry, our revenue would be 1 times 480, which is 480. If we sold the items for $2, well, we would multiply it by 20, which would be -40, add it to this, you would get 460. And if you wanted to find the revenue, you would take that 460 and multiply it by the number, so that was the number that you sold, and you multiply it by the price, which is 2, and you can see how we can come up with the revenue like that, because it's price per object times the number of objects. So the more expensive the object is, the less we're going to sell. So 24 is really close to 25. So let's see what happens. What is the revenue if the price is $24? So what we're going to do is we're going to plug in 24 in for P. So -20 times 24 squared plus 500 times 24. So get out a calculator. And let's see. So we have 24 squared, and then times that by 20. So that's -11,520. Yep. And then we need to do 500 times 24. That's 12,000. And then take 12,000 and subtract 11,520, we get 480. So the revenue is going to be 480. So that's how much money we're going to bring in. $480. What price P maximizes the revenue? What is the maximum revenue? Okay, so here is our revenue equation. Let me erase this, and let me zoom out a little bit so we can see the problem. So this is a parabola, and we want to find the p-value that we are at the top of the parabola. So we're maximizing the revenue, so we're at the highest point. So that's the same thing as finding the vertex. So part C is asking you to find the vertex. Well, all we have to do is find h, which is -b/2a. B is 500, so -500 over 2 times a -20, that's a here. So 500 divided by 40 is 12.5. So when the price is equal to 12.5, we're going to get a maximum revenue. So P is 12.5. But what is the maximum revenue? So that's just the price that maximizes the revenue. To find the maximum revenue, that's the K value of your vertex. And all you have to do is just plug 12.5 into your equation. So that's -20 times 12.5 squared plus 500 times 12.5. This piece is 6250. And then this piece is 3125, -3125. So subtract that from 6250, and we get 3125. So the maximum revenue is 3125. So that's the most money we can bring in from this object if we satisfy this demand equation. So when we charge $12.50 for this object, we're going to make the most money, bring in the most money. So what price P maximizes revenue? We found that, and we found the maximum revenue. Part D asks, how many units are sold at this price? What does that mean? Well, what we're looking for is X, because X gives the demand, which tells us how many units. Demand is how many we're trying to sell. So all we have to do is plug 12.5 into the demand equation. Okay, so for part D, X is equal to negative 20P plus 500. This is the number of units sold. So X is equal to negative 20 times 12.5 plus 500. So this is negative 250 plus 500, which is just 250. So we're going to sell 250 at this price. Part E asks us, what price should the company charge to earn at least $3,000 in revenue? So this should remind you of the inequality problems we have seen before. So what price should the company charge? So we're looking for P is equal to what? To earn at least $3,000 in revenue. So we want our revenue to be greater than $3,000. We want to make more than $3,000. We know if we charge 12.5, we'll make more than $3,000. But what will get us exactly to $3,000? So what range of prices? So this is setting the revenue equation, which we have written here. Negative 20P squared plus 500P because that is the revenue. You can see it right here. We want that to be greater than 3,000. Now we've done a lot of problems like this. We don't even really have to graph this to solve this now. We can just move the 3,000 over. We get negative 20P squared plus 500P minus 3,000 is greater than 0. We ignore this, we set it equal to 0, and we try to factor it. The first thing I would do is try to get out a greatest common factor. So notice that each one of these numbers is divisible by 10. So let's divide everything by 10, including the 0. I also don't like this negative, so I'm going to switch, switch all the signs. So 2P squared minus 50P plus 300 is equal to 0. Let's see if we can factor this. We want two numbers that multiply to give us 600, add to give us negative 50. 600 is 60 times 10. Oh, and I think I've already found them, which is great. Maybe. No, wait. 60 plus 10 is 70, so that's not it. Let's see. This breaks into 6, 10, and 10. They need to both be negative in order for them to multiply and give us a positive and add to give us a negative. So we can do, this is 5 and 2. I think 30 and 20 will work. If you multiply these two together, you get 600. And if you add them together, you get negative 50. So because this number in the front is not a 1, we can break this into 2P squared minus 30P plus a negative 20P plus 300 is equal to 0. And then we group, factor out what you can factor out. I can take out a 2P from the first one. I get P minus 15. Plus, and I think I can take out, let's take out the 20, the negative 20. So we get P minus And 300 divided by 20 is 15. Great. And then when you have it in the stage, factor out the p minus 15. Okay. And we can see that p is 15 and p is also equal to 10. So these are the intercepts. If we were to draw this graph, you can see that, well, we don't have to draw it. I want to avoid drawing it because I want to remember what we're doing and see if we can figure this out logically. So what did we do? We set this thing greater than 300 and we moved it over. So we're trying to figure out where the two graphs, this 3000, so maybe I'll just give you an idea of what this looks like. So this goes through 0 and it goes through 25. We know that the parabola is pointing down because we have this negative 20, so it's going down like this. We found the vertex. The vertex was 12.5, 31, 25. Because that was the maximum revenue and the maximum price was right here. And then we were trying to see when we were bigger than 3,000. We've done this type of problem several times. So what you do is you set the revenue bigger than this, this number here, 3,000. And you're trying to find all the x values where you're bigger than 3,000. Now, when we solve this, what's going to happen is we're going to get two numbers, 15 and 10. Which tells us that 10, which is right here, and 15, which is right here, that we are, between these two numbers, we're bigger than 3,000. So our answer is anything from $10 to $15, but not including 10 and 15, because that's when we're equal to 3,000. All right, let's move on. Another problem you're going to see in your homework involves a rectangular field. It says Beth has 3,000 feet of fencing available to enclose a rectangular field. Express the area of the rectangle as a function of x, where x is the length of the rectangle. And then for what value of x is the area the largest? And then what is the maximum area? For this type of problem, I like to draw a picture. So she has a rectangular field, and let's call this side X and this side Y. She has 3,000 feet of fencing and she wants to enclose it. Well, that means you're going to go along the perimeter. So X plus Y plus X plus Y, so I'm going to go along this side and then this side, this side, and this side. That's going to equal 3,000. So in other words, 2x plus 2y is 3,000. So that gives me an equation for the perimeter of my field. I want to express the area of the rectangle as a function of x. So I want to come up with an area equation, which we know the area of a rectangle is x times y. But I want to manipulate this so it's just a function of x. I don't want this y here. How I'm going to do that is I'm going to solve for y in this perimeter equation. That will give me a relationship between x and y. And then when I solve for y, I'll have something that just involves x, and I can plug it into the area equation. So for solving for y, we get, divide everything by 2, you get x plus y is 150. So y is 150 minus x. So you're going to take this and plug it into here. So we have x times 150 minus x is the area. And we can clean this up a little bit. We get that the area is negative x squared plus 150x. Okay. Now we have this area equation. Let me move it up so we can see it. And that's part A. For what value of x is the area the largest? This is asking us to find the vertex of this parabola. Notice that we have a parabola here. The parabola is pointing downwards. because we have a negative in the front. So since it's pointing downwards, the maximum of this parabola, which is what we're looking for, is the vertex. So we're going to find the vertex. And the vertex is negative b over 2a. And then plugging in negative b over 2a into the area function. So the h value, which is negative b over 2a, well, here is b over 2 times negative 1. So that is 75. So h is 75. And then to find the k value, we plug in 75 into our area function. We get negative 75 squared plus 150 times 75. So 75 times 75, this is negative 5625. And the other one is 11250. So from that, I'm going to subtract this 5625, and I get 5625. So that is our K. And so we found the vertex. Okay, from there, we found this is X. Remember, this is the X value and this is our Y value. And the Y value is the same thing as the area. So this number here is the value for which the area is the largest, which is 75. And the maximum area is this value here. Because remember, this is a point on the parabola, and the parabola gives us all the values of the area. So 5625 is part C. Okay, I have one more problem I want to do, and then I want to talk about, I think I'm only going to do one more of these. I think you should be able to solve most of these. So let me look at the problems we have. I think maybe we're going to do problem 14. Let me look at this problem. This one's very similar to something we've already done. So let's talk about 12 quickly. You're going to see this on your homework. You're going to have a projectile fired at an inclination of 45 degrees to the horizontal with a velocity of 100 feet per second. All of this information you don't need. What you're going to need is this piece right here, which is your quadratic function. So on your homework, you're going to have one similar. So this is what you want to pay attention to. Part A says, at what horizontal distance from the firing point is the height of the projectile a maximum? Maximum means we're finding the vertex of this parabola. So A and B is just talking about finding the vertex. We've already done something like this, so I don't want to do it again. Part C says, at what horizontal distance from the firing point will the projectile strike the ground? So if you remember from last section, we did a problem like this. This is just where you're setting your h, the height of the projectile, equal to 0. So you're finding your x-intercepts. So that's what you're going to do for this portion of the problem. Just set it equal to 0 and solve for x. Part D says use a graphing utility and graph the function from 0 to 350. So you just graph the function and zoom out until you get to from 0 to 350. And then you just verify your results. You can use desmos.com for that. And if you do this, whatever you got for the vertex, so whatever you got for the vertex, if you touch the top point of that graph, you'll see that A and B is the same thing as what you got. When you graph this parabola, you'll get the same thing. And you'll also see that these 2 points, whatever they happen to be, if you touch the graph on desmos.com, you'll get the same thing for part C. Okay, and then part F says when the height of the projectile is 50 feet above the ground, how far has it traveled horizontally? So all that means is the height is 50 and x is the horizontal distance. So you're just plugging in 50 here and you're solving for x, and that will give you part F. So if you have a homework problem like this, just follow those instructions I said in this video. All right, here is problem 14. I think we may have seen something like this a while back, and I want to go back through it. And then I'm going to talk about that homework question you're going to see. So it says a parabolic arch has a span of 120 feet and a maximum height of 25 feet. Choose suitable rectangular coordinate axes and find the equation of the parabola. Then calculate the height of the arch at points 10 feet, 20 feet, and 40 feet from the center. Okay. So we have a parabolic arch. It has a span of 120 feet. So what I'm going to do is I'm going to make an arch here, and I'm going to start at 0 and I'm going to go out to 120 feet. And that's because that's the span. And its maximum height is 25 feet. So here is the parabolic arch. And when you see parabolic, that means parabola. And so you just think of a parabola like this. And we don't need to graph this. We can if we want to. We can continue this function like this, but it doesn't really matter. Okay, so I chose suitable coordinate axes. You can see that I moved this parabola over so that we go through 0 and 120, and we go up 25. We want to calculate the height of the arch at points 10 feet, 20 feet, and 40 feet from the center. How can we do that? Well, let's talk about the center of the parabola. Because I'm putting this parabola between 0 and 120, we can find the vertex. We're already told that the y-coordinate of the vertex is 25. And we're also told that the vertex, because this graph is symmetric, the x value is going to be between 0 and 120, which is 60. So I have 3 points on this parabola. I want to find an equation for the parabola. Now the parabola can be written as ax squared plus bx plus c. So let's use some of these points. We know that we go through the point 0, 0. So if I plug in 0, I should get 0. So 0 is going to be equal to 0 plus 0. I'm plugging in 0 for x plus c, which tells me c is equal to 0. So that gets rid of this c here. The next thing is I have this point 120 comma 0. So when I plug in 120, I should get 0 for this function. So if I put 0 here, I have a times 120 squared plus b times 120. That's going to give us 0. So let's simplify that. So 120 times 120 is 14400. Okay, and then this is plus 120b. That's equal to, this is a here, is equal to 0. So that comes from this point here. And I also have another point, and I can use that to get a relationship between a and b. So here's one relationship. I can also solve for b from this one. So let's move the 120b to the other side. And I see that b is equal to, divide this number by 120, I get 120. So this is negative 120a. So that's one important equation I want to use. Now let's use this one. So when I plug in 60 for x, I should get 25. So the function, remember, is ax squared plus bx, because the c was 0. So if I plug in 60, I should get 25. So let's clean this one up. 60 times 60 is 3600. So this is 3600a plus 60b is equal to 25. And because b is negative 120a, I can plug that in here. And so I have 25 is 3600a plus 60 times negative 120a. Let's multiply 60 and 120. We get 7,200, so this is minus 7,200a. 3,600a is 25. So let's subtract. We should get 3,600. So we get 25 is negative 3,600a, and then divide. We get a is equal to 25 over negative 3,600. Now, let's see if this is divisible by 25. It is. So a simplifies. If we divide the top and the bottom by 25, we get 1 over 144. So this is the value for a, and I'm going to put that in my equation. In fact, I'm going to erase this so I can see all of this information here. Let's move this up a little bit, zoom out. So I'm going to start writing my equation. F of x is equal to a, which is negative 1 over 144 x squared, plus b. B is negative 120 times this, so b is equal to negative 120 times negative 1 over 144. Let's simplify that a little bit. These are both divisible by 2. Let's see if they're divisible by 4. They are. Okay, let's divide both by 12. So you're going to get b is equal to 10 over, I think this is 12, right? And then we can divide it by 2, and we get 5 over 6. So b simplifies to 5 over 6, and I'm going to put that there. And then we have plus 0. So here is the equation for our parabola. So we have found the equation of the parabola, and we chose a suitable rectangular coordinate axes. The next part asks us to find the height of the arch at points 10 feet, 20 feet, and 40 feet away from the center. So how we're going to do that, here's the center of the parabola, right? So we're just going to subtract 10 from 60, which is 50. Or you could add 10 to 60, and you would get 70. And then you just plug either one of these numbers into the equation, and you will get the height at 50 and 70, which is 10 feet away from the arch. And because this graph is symmetric with respect to this axis of symmetry, which is x is equal to 60, then you're going to get the same number here. So let's just plug in one of them. Let's plug in 50. So if we plug in 50 into this equation, we'll get negative 1 over 144, 50 squared plus 5 over 6 times 50. So 50 times 50 is 250, so negative 20 over 144. And then 50 times 5 is 250 over 6. I'm going to multiply this fraction, the top and the bottom, by 24. And the reason I'm going to do that is because I want the bottom to have 144 in the denominator, and 6 times 24 gives me that. So this is equal to negative 2,500 over 144 plus, this is over 144, so 250 times 24 is 6,000. And then we subtract 2,500 from that, and we get 3,500 over 144, which is about 24.3. So what does that tell us? So when we are 10 feet away from 60, this height is 24.3. So here and here, which makes sense because it is definitely less than 25, which is a good thing because this parabola is going down. And you can do this for 20 feet and 40 feet. I'm just going to do the 10 feet because the other two are very similar. So for the 20 feet away, you subtract 10 more, and you're going to plug in 40 into your equation, and then you can find that point here. And then to find 40 feet away, so you take 60 and subtract 40, and that would be 20, and you plug that into your function. All right, so the last thing I want to talk about is this homework problem. I'm going to read it to you, and we're going to talk about what we need to do to solve it. So it says a suspension bridge with weight uniformly distributed along its lengths has twin towers that extend 100 meters above the road surface and are 1,600 meters apart. Okay, there's a lot of words here. I'm going to start drawing a picture to help me interpret what's going on. So we have a bridge. Okay, I'm going to draw a straight line like this. And it has two towers at the end of the bridges, at the end of the bridge. So here's a tower and here's a tower. And they extend 100 meters. So the distance from here to here is 100. I'm gonna put a little knot like that. And they are 1,600 meters apart. Let me draw that a little bit better. So the distance from this tower to this one is 1,600. And the cables that suspend this bridge are parabolic in shape, and they're suspended from the towers, and they touch the road at the center of the bridge. Like this. So you have a parabola here, and you could continue this if you want to come up with an equation for it. Find the height of the cables at a point 400 meters from the center. Assume the road is level. So all you have to do, first off, you can find the vertex here. The vertex, if this is the road, we're going to assume that the distance from the ground is 0 here. And this is 1,600. So this tower right here, if we were to put this on XY axis, so let me maybe draw the XY plane here. So this is similar to the last question I did, which is why I wanted to go through it. You can say that this point right here, and this point, this one is 1,600, 100, because its height from the ground is 100 meters. And this point will be 0, 100. And how I got to this 1,600 is because they are 1,600 meters apart. This point right here will be halfway, so 800, 0, because it's touching the ground. So here I have 3 points that describe this parabola. You want to find the height of the cables at a point 400 meters from the center. So subtract 400 from this. What do you get? You get 400. So you want to find this point on this graph. So what you need to do is you need to come up with an equation for this parabola, and you can use what I did here. If you saw how I came up with this equation, I found A, B, and C. And by doing that, you should be able to plug in 400 into your equation, and that should tell you the height, how far you are away from the ground. One thing to notice is that this point goes through 0, 100, which tells you what C is. C is going to be 100. Before, the problem before, I was at 0, 0, and that told me that C was equal to 0. That's not the case for your problem. C is going to be equal to that 100, which means when you plug in numbers like the other points to find a relationship between A and B, you're going to have a plus 100 here because that C didn't go away. So be careful with that. And that should help you solve this problem.